So hi everyone, this is Mark,
And Allison.
And Alexandra.
and Jason is blowing us off today, so it's just the three of us. And we thought it would be useful to supplement the reading that you've got about doing modeling of mechanical systems, both from a qualitative perspective and a quantitative perspective, with maybe one more example where we actually kind of go through the modeling process in a video and show you some of the thinking that we're doing along the way. So that's what we're going to be talking about today. And Alex, I think you've got a question that you were sort of thinking might be interesting to talk about for this. So what's that
Yes.
question, I wonder?
So I thought about something that is extremely realistic. In particular, this idea of can we launch a man into space? So
I think we know the answer to that, don't we? Like, didn't NASA already do that?
potentially, but really, what about if it was with a cannon? I mean, I feel like it would just be much more interesting that way.
Oh, you know, there was that book, right? That Jules Verne book where they like launched people like, what was that? I don't know which one it was, but they
From the
launched
Earth to the Moon, yeah.
From the Earth to the Moon, right? They like shot them out of a cannon, right? That's really interesting. Could you
Yes.
actually? I wonder if you could do that.
Yeah. Would you be up for trying to figure out if we can come up with a model for this?
That sounds like a great idea.
All right, so I'm going to write this down, and you can tell me if you totally disagree with my question or if we should look at it differently. So, can we launch a man into space? So what could we, if we're thinking about this question,
Seems like
doesn't
we
make
should
sense.
refine that a little bit.
Yeah, I'm wondering how you can actually use a model to answer that question, Alexandra.
So, I mean, one thought that I had is if I went back to this Jules Verne book and sort of thought about it, is maybe we just have an initial velocity and say, would the man get there?
Oh, so the Jules Verne actually specify what the velocity is in the book.
He supposedly said there was some velocity that you could get there. I'm not sure if
it's
he's
kind
right.
of given an initial velocity,
Right.
is that sort of a sufficient velocity to get into space? Is that kind of the question?
Yeah, so given V naught, would he get there?
So I think you could frame it a little bit differently, and the reason I might frame it this way is that I think it would lend itself to some more exploratory type of modeling, is kind of how does the final altitude depend on the initial velocity of a person fired out of a cannon?
So how does the altitude, so we'll say h, depend on V naught, that velocity out of the cannon?
Right. And I just want to say something here. Notice that this sounds like an AP Physics problem, and it's not.
No.
Right? Why is this not an AP Physics problem?
Well, there's definitely atmosphere going on that's
Right.
playing a really big role, I would have to say, and some potential complexities with this cannon.
Okay. All right, so that sounds like a pretty reasonable question. I mean, another question you might ask is what cannon would you need to get a given V naught, right?
So maybe a design question, like what cannon would you design to get V naught
Yeah, and
Whatever it
maybe
is.
also to get not dead person.
and not kill the person? And not...
Yeah. So those all seem like pretty good questions, and I guess one of the things that maybe we're hoping that you'll take away from this is this idea you can think about multiple questions and then decide on one to start with, and maybe circle around that for a while and then change questions. So what should we start with here?
Well, figuring out what cannon design we need to accomplish something seems to depend on what we're trying to accomplish. So I think we probably don't want to start with the cannon design. We're probably going to have to look at the velocity and the altitude first.
Right. And I think I'd be inclined to look at how does H depend on V naught, and then that allows you to answer this question for given V naught, would he get
Right.
into space, but it maybe is going to give us a sort of more intuition about how the system behaves than the first question.
Right.
So let's focus on that middle one.
Yep, and then you could potentially use that to come back to the cannon
Yep.
design if that was your
Awesome.
passion, was designing cannons. Okay, so thinking about what's next, I think we should talk about how might the system behave if we're going to start to answer
Yeah, I think
this
maybe
question.
drawing some keyframes might be a good idea to try to think this through.
Yeah, so how will it, being the system, behave? So first off, we might have this initial phase of the actual launch, right?
So this is like we light the fuse, and some
All that good
explosive
stuff.
goes off in the bottom of the cannon,
Right.
and the person gets accelerated along the
And let's say so you have
cannon.
a person, little head there, and they're going to get released.
And so
at some
during
point.
that phase, they're like getting accelerated, they're getting pushed out of the cannon.
Right.
Okay.
We gotta add some clouds, just because.
Okay.
All right. So the second phase might be actually when they're going through the atmosphere towards space.
Okay.
So through the atmosphere. So we have our person, and they have some velocity, and they're going through the sky. Thoughts on anything to add? Or does that seem pretty what's happening at that point?
Sort of seems like what's happening. I guess one of the things that seems like important is that there's going to be some point when they're like out in space, and presumably as they get higher and higher, that atmosphere is going to be getting thinner and thinner.
Right. So the atmosphere is definitely something we've got to pay attention to as we keep moving
Right.
forward. And then there's the question of if they actually reach space, right? So there'd be something we think about, maybe some boundary.
Mm-hmm.
There might be some like dotted line before we see all the stars, and they're actually out in space. We won't presume any velocity at that point,
Right.
but
Okay, so we're not trying to get them into orbit or anything.
yeah, maybe we do that in a later class.
Yeah. So it seems like maybe one thing we might think about in this drawing is this question of, are we actually firing them at an angle, or are we just firing them straight up? And I guess my inclination would be to say initially, let's just shoot them straight up. Like, let's make it simple,
All right.
right?
So
Although we could do it at an angle. I don't know. What do you guys think?
Well, doing it at an angle allows us more flexibility in our model to investigate different initial conditions, but it's much simpler if we start just going straight up.
You know, let's do it with an angle because we'll have to use vectors. It's always good to use vectors. We like vectors, right?
Vectors it is.
All right.
All right.
So I think we've got a reasonable set of keyframes here.
Yep.
And maybe this is a good point to stop this video and sort of preview where we're going next. So what's our next step going to be?
So I think one of the next big things is going to be thinking about what are the parts of this system. Are we looking at particles, rigid bodies, flexible bodies, and what interactions might be taking place?
Okay, cool. Well, we'll come in the next video to talk about that.